Welcome one and all. In this video, we discuss about one of the applications of differential equations, that is nothing but orthogonal trajectories. So, in this unit, we are discussing about the first order and first degree differential equations only. So, that's why here the applications are also we are discussing about first order and first degree differential equations only. In that one, the geometrical applications that today we are discussing, in that one we have the syllabus orthogonal trajectories. So now what do you mean by an orthogonal trajectory and how to find out the orthogonal trajectories of a given family, that we will discuss now. So by the term orthogonal means we know that perpendicular means at the right angle. Okay. So now when and what do you mean by orthogonal trajectories? Suppose if one family of curves is given. Suppose f of x, y, c is equal to 0 represents a family of curves. So now if you get any other family g of x, y, some d is equal to 0, where d is also nothing but an arbitrary constant. So here c is an arbitrary constant and here d is an arbitrary constant. So if each and every curve of the first family f, okay, intersects each and every curve of the second family g at right angles, then we can say that f and g are orthogonal trajectories. Let me once again. If each and every curve of f is intersected perpendicularly or orthogonally with each and every curve of g, then we can say that f and g are orthogonal trajectories. Now first of all, let me tell you what do you mean by a family. Family means it is nothing but consisting of infinitely many curves satisfying the same property, one property. Let me tell you with the help of one small example. Suppose if we have a curve y is equal to mx. If I say that m is a constant, then all of we know that this y is equal to mx represents a straight line passing through the origin. Only one straight line. Y is equal to mx. If m is a constant, then that equation y is equal to mx represents a straight line passing through the origin. Suppose for example, the same if we have y is equal to mx, where m is an arbitrary constant, then this one represents a family of straight lines passing through the origin. So family of straight lines passing through the origin means the straight lines passing through the origin, maybe from positive side or negative side, something like this. How many we will get it? Infinitely many straight lines passing through the origin. Suppose this is the x-axis and this is the y-axis. So here that is the difference. Okay, so if m is an arbitrary constant, then y is equal to mx represents a family of straight lines. What is the common property of straight lines? All are passing through the origin. Okay. Here also m is constant. So for this straight line m is constant, for this straight line m is constant, for this straight line m is constant, means m is arbitrarily constant. So like this here, this y is equal to mx, where m is an arbitrary constant, represents a family of straight lines which are all passing through the origin. Okay, so the equation y is equal to mx, if m is a constant, represents only one straight line passing through the origin. Okay, once again, if y is equal to mx, if m is an arbitrary constant, represents a family of straight lines passing through the origin. So that much of difference is there in between a constant and an arbitrary constant. The family of equation consisting of an arbitrary constant. So that's why this represents a family of curves, means infinitely many number of curves which are all having the common property. So here in this example, what is the common property of all these straight lines? All these straight lines are passing through the origin. So that's why all this comes under one family. Okay, so similarly here also we have two families. So families are also may have more than one arbitrary constant also. May have one arbitrary constant, two arbitrary constants, and more than that, n arbitrary constants also you may find. But here we are discussing about the family of curves consisting of only one arbitrary constant, because here we are discussing about the first order and first degree differential equations applications only. So that's why here we are discussing about the families which consists of only one arbitrary constant. And now once again coming back to the definition of orthogonal trajectories means, so if F the family of curves F is given, then the family G is said to be an orthogonal trajectory of F if each and every curve of F intersects each and every curve of G at right angles or orthogonally. Then we can say that F and G are orthogonal trajectories. Okay. So now what is the procedure to find this and all? Now we will discuss. Suppose for example here itself we will see. Now we will see the procedure. Let me tell you in another slide. Okay, now f of x, y, z, x, y, c. So this is the given family. Okay, so this is the given family. Then for this family, how can we find the orthogonal trajectory? Okay, so this is the given family. Then our first job is we have to form the differential equation for this. Form the differential equation. So how to form a differential equation for the given family that I think we have studied in your +1 or +2 level, or form the differential equation, in other words, or eliminate C. Eliminate the arbitrary constant. So here as we have only one arbitrary constant, so therefore we will get only the first order differential equation. So I am writing that with some capital F of x, y, some first order. First order means suppose if y is dependent and x is independent, then we may write like this. So now the arbitrary constant is eliminated and we got a differential equation f of xy dy by dx is equal to 0. What is this? This is the differential equation of the given family. So now what we have to find? We have to find the orthogonal trajectories. Orthogonal trajectories means, I already told that perpendicular. Perpendicular means from the basic geometry we have that two curves are said to be orthogonal if they product of their slopes is nothing but -1. Okay, so then only we can say that these two curves are intersecting perpendicularly whenever the product of their slopes is equal to -1. So similarly, we can find out the slope of a curve by using the derivative, first order. Suppose if y is equal to mx or y is equal to f of x is a given curve, then dy by dx gives us the slope of the curve. So therefore here, if we have to find out the slope of the curve which intersects the given curve at right angles, in the sense from this if we observe m1 into m2 is equal to -1, means m2 is equal to -1 by m1. So by using that, so if dy by dx is the slope of the given curve, then what is the slope of the curve which intersects this at right angles is nothing but minus dx by dy. So therefore, now you replace dy by dx with minus dx by dy. I think all of you got the clarity. So because what is that? m1 into m2, once again may I repeat, m1 into m2 is equal to -1. In the sense, m2 is equal to -1 by m1. So if dy by dx is the slope of the given curve, then what is the slope of the curve which intersects this at right angles? What is that? m2 is equal to -1 by m1. In the sense, what we get? -1 by dy by dx. In the sense, minus dx by dy we will get it. So therefore, to find the orthogonal trajectory of small f, here we have to replace this slope dy by dx with minus dx by dy, then you can write it as some g. So g of x y minus dx by dy. Okay, and just I am changing that name. So this is nothing but the differential equation of the orthogonal trajectory of f or otherwise of the given family. Okay. Now to get the orthogonal trajectory, what we have to do? We just solve this one. Then we will get an arbitrary constant once again. So this is nothing but the orthogonal trajectory of f. Means once again, let me tell you the procedure what we have to do. So f of x by c is equal to 0 is the given family. Then for that you form the differential equation. In the sense you have to eliminate that arbitrary constant. Then we will get some f of x y divided by dx is equal to 0. So this is nothing but the differential equation of the given family. And later on what we have to do? You have to just replace dy by dx with minus dx by dy to get the orthogonal curve which intersects it orthogonally or otherwise. So means I am writing that one as with some g of xy minus dx by dy is equal to 0. This is nothing but the orthogonal trajectory of the given family f is equal to 0. And to get the orthogonal trajectory, what we have to do? So now we have to solve this new differential equation. Then we will get an equation in the form of consists of one arbitrary constant also, which is nothing but known as the orthogonal trajectory of the given family. Means this process consists of formation of a DE and solving of a DE. So the two procedures are involved in this one. So this is simply about the entire procedure in how to evaluate or how to find out the orthogonal trajectory of a given family. Now let us discuss this with the help of one small example. Okay. Now we have a problem like this. Find the orthogonal trajectories of the family of circles passing through the origin and having their centers on x-axis. But here the equation of the family is not given. We have to find out the equation of the family also. Okay, so find the orthogonal trajectories of the family of circles passing through the origin and having their centers on x-axis. So first of all, let us see the equation of such type of circles. Okay, so given that the circles are passing through the origin and having their centers on y-axis or x-axis. Suppose this is y-axis and this is x-axis. So we have a circle like this. Suppose for example passing through the origin and having center on x-axis. Means here suppose this is the center here. It is of the form. Internally it is on the x-axis, means we know that it is of the form some a0. Means a is nothing but the distance from here to here, from origin to this. So therefore, what is the general equation of a circle actually? X minus a whole square plus y minus b whole square is equal to r square. This is the general equation of a circle where AB is the center and r is the radius. But now with the help of this one, if we simplify, then x minus a whole square, and in place of b what we have 0. Okay, so y minus 0 whole square is 0. What is the radius here? A is nothing but the radius here because the center lies on the x-axis. So therefore, if we simplify this, then what we get? X square plus a square minus 2ax plus y square is equal to a square we get. So a square and a square cancel. Then we can write it as x square minus 2ax plus y square is equal to 0. Or otherwise, simply we can write it as x square plus y square plus 2gx is equal to 0. So this is the general equation. Directly if you remember this, then we can write it And otherwise we can find out like this by using the basic definition also. So now, as I said, this is nothing but the family of circles. Means all the circles crossing through the origin and having centers on x-axis we find like this. So maybe all the circles like this. How many circles we find? Infinitely many circles. May not be on this side, on the negative side also. That's why in general here we wrote 2gx. That may be positive side or negative side, whatever it may be. So like this, like we may have infinitely many circles passing through the origin and having centers on x-axis. So for that family, now the general equation is x square plus y square plus 2gx is equal to 0. So let me write once again. So the equation of the given family of circles is, what is that? Here x square plus y square plus 2gx is equal to 0. Is what is that? X square plus y square plus 2gx is equal to 0. So we just take it as equation 1, and here we know that g is nothing but the arbitrary constant. In the sense a here, otherwise g here, because in general we wrote it, so that's why that one. Now we'll find out the step 1. So what we have to do in the step 1? We have to find the differential equation for the given family. Okay, so now we write to find the to form the, like that also we can write to find the differential equation of 1. So like this you take it in step 1, we can do like this. So for that, here first of all we have to identify how many arbitrary constants are there in the equation. So here we have only one arbitrary constant. So therefore we have to differentiate this equation only once. So now we would differentiate equation 1. Simply I am writing like this. So with respect to x on both sides, then we get derivative of x square is 2x, derivative of y square is 2y. But with respect to x we are doing, so that's why 2y into dy by dx plus derivative of 2g is constant, x is 1 is equal to 0 we have. So this implies what we get by cancels out 2 on both sides, then we get x plus y into dy by dx plus 2g into g is equal to 0 plus g is equal to 0. So means now we can write, so g is equal to minus of x plus y into dy by dx. Now we have to replace, this is the g value what we got. Now we have to substitute this g value in equation 1. Therefore by substituting the g value from equation 2 in equation 1, we get what we get. So x square plus y square plus 2x into g. What is the g? G here we have minus of x plus y into dy by dx is equal to 0. Now you just first of all simplify this, then what we get? So this implies we get x square plus y square minus, so 2x into x means minus 2x square, next plus 2xy into, sorry here we have minus, so minus here we have minus 2xy into dy by dx is equal to 0. So here we have x square minus 2x square means minus x square will get plus y square minus 2xy into dy by dx is equal to 0. If you want, you can multiply with the negative sign, then we will get x square minus y square plus 2xy into dy by dx is equal to 0. So this is the differential equation of which is the differential equation of the given family. So if you want, you can write which is the differential equation of the given family is F if it is taken as 1. Okay, what is the next step we have to do? Next step 2 we will write it. In step 2 what we have to do is we have to replace dy by dx with minus dx by dy. Okay, now you take step 1 is over. In step 2 what we have to do? Replace dy by dx with minus dx by dy in equation 3. Okay, just if you observe this, here what we have in equation 3, we have to replace dy by dx with minus dx by dy. Now what we have? X square minus y square plus 2xy. So then we will get x square minus y square plus 2xy into, in place of dy by dx we have to write minus dx by dy is equal to 0. Okay, then once again if you want you can simplify. What we get? X square minus y square minus 2xy into dx by dy is equal to 0. What is this? You take it as equation 4, which is the differential equation of the orthogonal trajectory of equation 1. Okay, so therefore now we have to solve this equation, that you take it as step 3. So we are solving this problem, or we are evaluating the orthogonal trajectory of the given family in 3 steps. In step 1, formation of the differential equation. In step 2, we have to replace dy by dx with minus dx by dy in the differential equation. And in step 3, we have to solve this differential equation. So that you write to solve equation 4. Okay, now once again you consider this equation 4. From 4, what we have, what is that equation? X square minus y square minus 2xy into dx by dy is equal to 0. Okay, so if you want, we can solve this equation in so many methods. One is here, if you observe, all the terms are nothing but of same degree. Here it is a degree 2, and here also it is degree 2, and here third one is also of degree 2. Means this is nothing but a homogeneous differential equation. So therefore, we can take the integrating factor as 1 by mx plus and y. Like that we can solve it. Or otherwise we can check whether can it be converted into linear or Bernoulli. Like that also we can check and we can solve this. Okay. Now we will see how to solve this one. So now here we have. So let us try in exact differential equations. So what we have? X square minus y square into dy minus 2xy into dx is equal to 0. So many methods are there. We can solve. Okay, in this method, in the exact method, we will try to solve this. In the sense, just you multiply with the negative sign, then we can write it as 2xy dx minus of x square minus y square into dy is equal to 0. So just you take, let it be m, and this may be some n, because it is in the form of m dx plus n dy is equal to 0. Now we will check whether it is exact or not. So for that one, you calculate dou m by dou y first of all. So if you calculate dou m by dou y, then what we get? 2x only, because y is a constant and its derivative is 1. So 2x into 1 means 2x. Similarly now you calculate dou n by dou x, means the partial derivative of n with respect to x. So here we have minus x square plus y square. So derivative of x square is 2x and derivative of y square is 0. So means this is nothing but minus 2x. So dou n by dou y is not equal to dou n by dou x. So therefore dou n by dou y is not equal to dou n by dou x. So therefore we can say that, okay, for example you take it as some equation 5. Therefore equation 5 is not exact. So now which method we have to take, means what is the integrating factor we can take. So first choice is we can take integrating factor as 1 by mx plus ny, because this equation 5 is exact. Or otherwise, is there any other one we can, so that we can easily solve that. Suppose if you take dou m by dou y minus dou m by dou x 4x by 1 by m into, means you have to take 1 by n into. Okay, 1 by, let me check it here in the margin. So suppose if I take 1 by m into dou n by dou x minus dou m by dou y, if it is a function of y alone, then we can go with this. So dou n by dou x here we have minus 2x, minus dou m by dou y means minus 2x. So divided by m means 2xy we have. So totally we will get a function of x alone. So therefore here, instead of taking 1 by mx plus ny as an integrating factor, we can take 1 by m into something else as an integrating factor. So like this we have to check it in the margin, and we can go for the conclusion that which one we can take as an integrating factor. Okay. Now we will consider this. Okay. Now you consider. Now consider 1 by m into dou n by dou x minus dou n by dou y. Just we will consider this. Okay. So which is equal to, what is dou n by dou x? Dou n by dou x we have minus 2x minus dou n by dou y we have 2x. Okay. So divided by, so m, what is m here? M is 2xy. So here what we have, minus 4x by 2xy. Minus 4x by 2xy we have. So we just, if we simplify this, then we will get minus 2 by y. You can call it as some g of y, which is a function of y alone. Which is a function of y alone. So if you find it is a function of y alone, then the integrating factor, we know that. Therefore, the integrating factor of equation 5 is, what is that? IF is equal to e power integral g of y dy. This is the integrating factor. So this is equal to e power integral g of y. What is g of y? G of y here we got it as minus 2 by y. So minus 2 by y dy. So which is equal to e power integral of log 1 by y means, integral of 1 by y means log y will get, but minus 2 here we have. So therefore by applying the basic logarithmic formula, e power will get e power log of 1 by y square. So e power log of 1 by y square means we will get 1 by y square will get. So this is the integrating factor. The integrating factor of the d is 1 by y square. Now we have to multiply the equation 5 with this integrating factor 1 by y square, and then we have to solve the d. Okay. Now we will go for that. So therefore by multiplying equation 5 with 1 by y square we get, because 1 by y square is the integrating factor. Okay, so first one we have 2xy by y square dx minus of 1 by y square into what here we have, we will check it. So what is that equation 5 we have here? Minus of x square minus y square into dy. Minus of x square minus y square into dy is equal to 0. We will write it. Now we just simplify this, then we will get 2x by y dx minus of x square by y square minus 1 into dy is equal to 0. Okay. Now this is of the form sum m1 dx plus m1 dx plus n1 dy is equal to 0, which is nothing but an exact dE. It is clear? Which is an exact differential equation. So therefore we can find its general solution by using the formula as integral of treating y as a constant m1 dx plus integral of treating or integral of the terms in n1 which are free from x into dy is equal to c. Now you substitute all the values. This implies integral over treating y as a constant. So what is m1 here? m1 is 2x by y into dx plus integral of. So in n1 we have to take the terms which are free from x. So in the first term we have x square by y square, x is there, we cannot take it. Next we have 1, but minus 1, minus of minus plus 1 we have. So only 1 into dy is equal to c. This is nothing but an arbitrary constant. Okay. Now you just evaluate that integral. So there 2 by y is a constant. 2 by y is a constant, and then what we have here? Only x into dx. So integral of x is nothing but x square by 2. And coming to the second one, integral of dy. Integral dy is nothing but y is equal to c, the arbitrary constant. So here 2 cancels out, then we will get, and if you take y also as LCM, then we can write it as x square plus y square plus some c1y is equal to 0, where c1 is nothing but minus c, we can write it. So this is nothing but the solution of the equation 5, or otherwise finally, which is nothing but, which is the orthogonal trajectory of equation 1. Okay, so can anybody tell me what is that? It also represents a family of circles passing through the origin but having centers on y axis, because here we have so c1y, so means it represents a family of circles passing through the origin and having centers on y axis. So finally, actually what is our family? Our family is, otherwise the given family is x square plus y square plus 2gx is equal to 0. This is a given family, and for this what is the orthogonal trajectory? That what we got, x square plus y square plus c1y is equal to 0. So this is the orthogonal trajectory for the given family x square plus y square plus 2gx is equal to 0. So like this we can find out the orthogonal trajectory of a given family in 3 steps. Once again let me tell you, in step 1 we have to find, or we have to form the differential equation of the given family. In step 2 we have to replace dy by dx with minus dx by dy, and in step 3 we have to solve that new differential equation, and then finally we will get the orthogonal trajectory of the given family. So like this very easily we can find out the orthogonal trajectories of the given family. Thank you very much.